you. Our next speaker is Yaroslav Kuzmin from the Siberian branch of the Russian Academy of Sciences to speak about obsidian provenance in Northeast Asia, gaining solid evidence for prehistoric exchange and migrations. Please.
Good afternoon, everybody. Thank you for inviting me here. I'm very pleased. And let me just briefly introduce the results of our research in Siberian forest. Oh, sorry. So that's the place where I live and work. So it's very nice in summer, but in winter, beware, it's quite cold. It's right in the middle of Russia, though. So that's a famous Siberian research center, about 40 research institutes. So I'm fortunate to work here for the last 12 years. And just to tell why this obsidian is important. So because it seems that obsidian, which is essentially waterless volcanic glass, is most probably the best known commodity of rock, which can be used to study prehistoric contacts and migrations. And that's what it looks like. It's often glossy, so, and very sharp. The sharpest, edge in the world, that's the obsidian. And another point is that it turned out throughout more than 50 years of obsidian research that practically each obsidian primary source, geological obsidian, has its own geochemical signature. Therefore, by doing geochemical analysis, which are quite routine, one can establish the particular source from where obsidian artifact was acquired, either directly or indirectly. That's another issue. Having this solid information about the source and the artifact, one can derive some conclusions about the speed of migration, direction, and the way it was delivered directly or indirectly. So that's just one of the best examples is the wedge-shaped microcore and obsidian microblades. That's taken from one of the sites in Geopark in Hokkaido, Japan. Highest quality obsidian. So how we are doing this kind of research? That's just brief picture of obsidian distribution of sources and a small signs, and the dotted line, that's more or less spatial distribution of the artifacts. As you can see, obsidian is quite common in Mediterranean and surrounding part of Europe and Asia, North and South America by the Pacific coast, Oceania, New Zealand, Southern Seas, New Zealand, island Southeast Asia, East Africa, African Rift, and also Northeast Asia on the surrounded by this red figure. That's the area I like to talk today. So, fortunately to me, I was in contact and then working together with people from the Research Reactor Center, University of Missouri. Believe me or not, that's a proper nuclear reactor. Small though, but still operates. And what is important, that all our analyses were done in the same laboratory using the same analytical standards, reference samples, and so on and so forth. Therefore, they are directly compatible, which is not always the case. And sometimes the confusion arises. When different methods and different standards were used and so on, people already realized they need a calibration. We need the reference samples, then compare, and then arrive to the common number. So how the research is organized? When you start, you need to establish this geological sources. You go to the field and you collect the obsidian rocks or pebbles from the river, pebbles from the lake beach, which we did. So, and you need to know as much as possible about geochemistry. The best method is neutron activation analysis, which gives you the content of 28 elements with very high precision. Although method is destructive and not cheap, but extremely effective. Another possibility is to do the non-destructive method, X-ray fluorescence analysis, which is much cheaper. The equipment is smaller, but it gives you content of 14 elements. So next step is the grouping of results from different sources. As I said, each source practically has its own geochemical portrait, and then determine the source. This was done originally by Mike Glasscock and his colleagues in 1998, and turned out extremely successful. It's applied, they apply the statistics, cluster and discriminant analysis. So then we have the signature of the sources. Next step would be to analyze artifacts and match it to the sources. But because we know the whole geochemical portrait, we don't need to run 28 elements on the artifacts, for example. 5 to 7, 10 elements would be enough. But without the first step, it wouldn't be possible. So you need to do a lot of geochemistry, and then you can do less. And then you arrive to these diagrams. You select pairs of elements, and then you can see these highlighted names. That's obsidian sources, and each ellipse is 90% probability. And you can see that, for example, Northeast Asia, they're quite well separated. So even though some sources are, I don't know, less than a kilometer apart, but they still geochemically and statistically differ. Therefore, we can find out from which particular source or subsource people, were acquiring obsidian. Another important issue is the long distance exchange and trade, and down the line transport and exchange, which was originally, this idea was created by Professor Colin Renfrew, who is with us currently. So what is important to know, it's a semi-empirical value, although practically I think very reasonable, that when distance between site and the source exceed 300 kilometers, it's very likely that people did not acquire this obsidian directly. Because 10,000 years ago, to travel 1,000 kilometers, it's like today, fly to the moon. So you have to know where is the source, but how do you know 10,000 years ago? Therefore, the idea of the long distance exchange and through the chain of middlemen or through some kind of primitive trade fairs and so on, it's very important, and we use it widely. And I will demonstrate how. So now the sources, they look like in Northeast Asia. This is sourced in the maritime province in Russia, southern Russia, near city of Vladivostok. That's not a source which is usually associated with the acidic rocks, rhyolites. Source which consists of basalts. Basaltic hot lava come to the cold surface and quickly become cool, and therefore the crust of the pure glass appear. This glass has been eroded and went down the slope to the river channel, and then it's rounded, and that's how people on the bottom acquire this obsidian. So it's a basaltic, so-called hyaloclastite. Second, that's famous Japanese sources. They're rhyolitic, they're associated with acidic rocks, usual situation in the Pacific Rim, for example, and they are real standing outcrops, highest quality obsidian, it's extrusions or lava flows. So, and people acquired either directly or through the erosion, which brought the pieces of obsidian to the river channels, and people picked it. So that's another source, which is the latest one we studied. It's on Chukotka, it's next to Bering Strait. And it was kind of mystery for a while, where obsidian, in which kind of rocks, which rocks contain obsidian. turned out we studied this place and we found obsidian only on the beach. Nice rounded pebbles, highest quality obsidian, and these outcrops of ignimbrites don't have any obsidian at all. Turned out the geologists who suggested it, they misidentified something. But these pebbles can be considered as the primary source as well. Therefore, people already selected, there's no cracks in it. It's excellent obsidian, you can see, and people use it. So we consider it as a primary source. And now I would like to show the results of our matching between sources and sites. Okay. So this is the result of our 25 years of work. So you see this, each symbol is either yellow or red or just white or this kind of turquoise. That's obsidian source, and each small dot, that's the site where obsidian from this source was identified geochemically. What is important to see that the distances between source and sites often exceed 500, 600, 700 kilometers, and in several cases more than 1,000 kilometers between site and the source. And as I said in the beginning, all analysis done in the same laboratory, using the same analytical standards. It's extremely safe data. It's not surprising because obsidian was very valuable material and people acquired it either directly or through chain of exchange and trade and so on. So that's the situation in Northeast Asia. So from this data, you can derive, solid information about movement of people, contacts, sphere of interaction, and so on and so forth. So just as example of these huge exchange networks, there's a source which exists on the border between China and North Korea. We call it Pektusan. It's nearby. So we're working still on this. But we identified this obsidian at the sites which are separated from the source, like in Russian Far East, the upper part, 720 kilometers, and southern tip of Korean Peninsula, 800 kilometers. So that's a huge interaction sphere. Some of this obsidian, of course, it's in three Northeast Chinese provinces, Jilin, Liaoning, and Heilongjiang, too. So, moving further, that's the Kamchatka Peninsula, about 40 sources. Some of them you need thousands and dozens of thousands of dollars or euro to reach, unfortunately, because they're in a remote place, you need to fly helicopter, terrible prices. But we acquired some good information, and you can see the range of the distribution of obsidian, 560, 530 easily. And Kamchatka Peninsula, it's like island of Borneo in terms of you can't penetrate it through. So the speed of your movement would be 0.5 kilometer per hour or so. But people see how they travel. One more thing I want to mention quickly. That's another huge interaction sphere. The source is on Chukotka, which I mentioned, and each red dot, that's an archaeological site where obsidian was found. Even across the Bering Strait, distance 1,000 kilometers. And the most ridiculous case, in good sense, is the Zhokhov Island in the high Arctic. I briefly come to this. But first of all, I would say that these main networks of prehistoric exchange and trade of obsidian in the Russian Far East neighboring part of Northeast Asia, which we reconstructed, show us that the scale of these exchange networks is very large and distance cover 100,000 square kilometers. Actually, we estimated one of the sphere 4 million square kilometers. So enormous distance, even today, enormous size. And before, this information was hardly available, and now we can use it in order to make conclusions about the movement of people and exchange since Upper Paleolithic. 30,000 years, 80,000 years ago. Already we have data for that. And another issue which I would just skip, somehow people often use obsidian not from one source, but from several. Why on earth they did it, I don't know, because quality of obsidian is the same. Let's just show us the strategy of obsidian acquisition. Distances are great. So, Zhokhov Island, quickly, it's an extremely remote place, 76 degrees north. George DeLong missed it, Russian expedition 1914 discovered this island. It's a incomplete permafrost, but it has a domestic dogs and pieces of the wooden sledges which were used to travel. So 80 obsidian artifacts from this site were recovered. We analyzed 14 of them and arrived on the right-hand side. You see they all match this obsidian source in the Kamchatka Peninsula. If you try to reconstruct, because that was 8,000 years ago and sea level was not high as today, people traveled not even 1,500 kilometers, but much longer, up to 2,000 kilometers. But I bet they didn't do it in one go. So there were some primitive exchange points, trade fairs, and so on existed. Therefore, they succeeded. And last issue I want to very briefly raise. We can use obsidian provenance studies to find out about the seafaring in Paleolithic. So 3 regions in Northeast Asia. One is Sakhalin Island. When the sea appeared, the right-hand side, people were still shipping obsidian. After the last glacial maximum, sea level rose, but people were still shipping obsidian using boats. There is no other way. 40 kilometers of open water. The same between South Korea and today Kyushu Island. Even during the last glacial maximum, the strait existed, and people needed to cross 20 kilometers of open water. They did. And the last and the most interesting one is the small obsidian source in the Kozujima, outside of central Honshu Island. And 38,000 years ago, people brought obsidian by boats. Although, if you assume they didn't have helicopters, across the rough water, 40 kilometers, and they were still able to do so, of course, with the help of marine transport. My colleague Tsutsumi-san reconstructed this. I don't know how it's reliable, and some angry birds reminds me a little bit of Hitchcock's bird, but people succeeded. So this source was very important and was widely used. And I would like to acknowledge my several colleagues and friends with whom I've been working together since 1992 from different countries, including Russia, United States, Japan, Korea, and United Kingdom recently. And of course, I'm very pleased to acknowledge the selection of our research by post-Shanghai Archaeology Forum. Thank you very much. And that's our crew in one of the sources on Hokkaido Island from different countries. And if you would like to come to Russian Far East, you are very welcome. Thank you very much.
Thank you.